Good afternoon, everybody, and welcome to today's Intel webinar, Getting the Most Out of Intel Fortran Studio. My name is Kevin Askew. I'm the Director of Sales here at TechXtend, and I want to welcome you on behalf of Intel and TechXtend. Today's agenda will include a brief overview on the TechXtend-Intel relationship, then we'll get right to the webinar hosted by Steve Lionel from Intel Corporation. TechXtend is a evaluated reseller of developer and infrastructure tools. We can be found on the web at www.techextend.com. We are an elite Intel partner, and Intel's solution sets fall under our ALM Worldview ecosystem. Under that worldview, we provide industry-leading tools for your end-to-end development needs, including defining, designing, developing, testing, deploying, and managing. Without any further ado, I will now turn things over to Steve from Intel for the Getting the Most Out of Intel Fortran Studio webinar. Steve?
Thank you, Kevin. I see somebody who is saying that they can't hear us, but at least I could hear you pretty well, Kevin. So I'm going to talk about Intel Fortran Studio XE 2011, which is the full name of the product. And I'm going to give an overview of what's in Fortran Studio XE, details on the individual components. I'll be talking about examples of the productivity and performance enhancing features of all of the tools that we provide. And at the end, there's information on a discount from TechXtend, plus there should be plenty of time for Q&A. Fortran Studio XE is a new collection of tools, although the tools have been around for a year. Back in November 2010, we introduced Intel Parallel Studio XE, which included the Intel Fortran and C++ compilers, plus some productivity and performance enhancing analysis tools, Intel Inspector XE and Intel D2 Amplifier XE. At that time, we would sell a package that included all of those tools, both C++ and Fortran and the analysis tools. And there was a subset for C++, where you got C++ and the analysis tools. But some of our Fortran customers would say, well, I don't use C++. I just want a Fortran Studios. Well, now we have one that includes the Fortran Composer XE product. And the visual is the word that we use on Windows, and on Linux, it's just Intel Fortran Composer XE. It includes the Intel Math kernel library. Then there's also the Intel Inspector XE product and Intel D2 and Amplifier XE. There's another feature of this suite, which is not an individual product feature. It's called static security analysis, and I'll spend quite a bit of time later on in this presentation on static security analysis. Intel Fortran Composer XE, or Intel Visual Fortran Composer XE for Windows, is a highly optimizing Fortran compiler for IA32 and x64 or Intel 64 platforms. It is derived from the old Compact Visual Fortran and the DEC Fortran products, and because of that lineage, it's highly compatible with Compact Visual Fortran. Although there are still some people who are using Compact Visual Fortran, most of our customers find that they simply need to do a rebuild with Intel Visual Fortran, and they're good to go. It's a near complete implementation of Fortran 2003, and some of the major features from Fortran 2003 that we support are the object-oriented features, polymorphism, type extensions, type-bound procedures, type-bound operators, generic operators. There's many, many more. One nice feature which you won't find in a lot of Fortran compilers right now is allocatable deferred length character. This is sort of a varying length string feature in the Fortran 2003 language, and it's available in Intel Fortran. And also asynchronous I/O, which many applications can use to overlap I/O with computes to get better runtime. We also support some major features from the recently approved Fortran 2008 standard. Do concurrent is an easy way of doing things in parallel in a do loop type environment. And coarrays is a major feature of the Fortran 2008 language that is a parallel processing feature that allows you to take your parallel application and run it not only on a single system, but shared across a cluster of systems. I'm not going to talk about those features today. If you want some more information, you can look at our website, ask on our user forum, or if you perhaps want to hold a question to the end, and I can talk a little bit more about that. But today I'm going to talk about the productivity and performance enhancing features of the compiler and the analysis tools to help you get the most out of the whole suite. I talked about the compiler being an optimized compiler, and we take performance very seriously. Here is a chart from an independent tester which compared a number of Fortran compilers on the same platform. And you can see here, this is just from a few days ago, the Intel compiler was by far the best of all of the competitors that were chosen there. Well, okay, so Intel has the best compiler on an Intel processor. But some of you may have non-Intel processors and may think that you're giving up something by using Intel compilers on your non-Intel processors. Well, that's not true. If you look here at this other chart where they were running here 64-bit Windows 7 on a non-Intel processor, you can see again that Intel is the fastest. So whichever platform, whichever CPU maker you choose, of course we would prefer that you buy Intel. You'll get the best performance with Intel. But you will get excellent performance, and you won't do better, really. You shouldn't do better by using the Intel tools with any processor that we support. And we do support non-Intel processors. We often get the questions of which options do I choose for best performance? And that's perhaps a multi-hour presentation in its own. But there are a few things that I like to suggest that people try that are easy to do and often can result in significant performance gains. The first is an option called /fast or -fast if you're using running on Linux. And you would use this if you're going to run the program on the same system that you're building on, because one of the options it implies is a thing called xhost, which says compile for the processor that I am doing the compilation on. And this also implies a number of other options which we have found taken together generally give you best performance, or at least very good performance, better than the defaults, although the defaults are also pretty good. So try that. You will want to test it to make sure that your program gets the answers that you want, that it actually does give you better performance. It will slow down the compile time a bit because it raises the optimization level. But this will help, especially if you're using one of the newer Intel processors. Another thing to try is our automatic parallelization /qparallel or -parallel. What this does is looks for loops and array operations in your normal Fortran code and sees if they can be run in parallel. It's a little bit conservative by default, but we've been working hard the last couple of releases to get good results from ordinary programs. So certainly give it a try if you're using a multi-core or a multi-processor system. Also, we recently added a feature called guided auto parallelism, or GAP, and this allows the compiler to give you advice on changes that you can make in the source that would help the compiler parallelize or vectorize your application. I have some example of using guided auto parallelism on the next slide. So this is something that you can use to see if there are little tweaks you can make to your code that can help the compiler optimize your program better. Make sure the runtime checking is off. Sometimes people put in build scripts while they're debugging, and they enable things like bounds checking that can have a performance impact, so make sure those things are off. If you're building on Windows, a debug environment has many of these checks on, but a release configuration has them off. Also, Intel Math Kernel Library, which I don't have an additional slide on here, but you can certainly look for more information on our website, is a large collection of highly optimized, parallelized advanced mathematics routines that can also often be just dropped into applications where you might have written your own routines for things such as BLOS or fast Fourier transform or linear solvers. And I have seen customers tell me that they got a 7x or even 20x performance improvement by simply replacing the use of a generic library routine with Intel Math Kernel Library. So these are options that don't require a lot of effort. You try them, and they may significantly improve performance of your application. Here is an example of gap diagnostics, guided autoparallelism. This particular one comes from a sample that we provide with the product. And it's talking about a loop where there is a variable t that's referenced in the loop. And it says, well, if you assign a variable to t to make sure that it's not trying to reference a value of t that came from some previous loop iteration, then it knows that it can run those things in parallel and also helps with vectorization. It gives you advice to say, well, make sure that in the program t is being used in an appropriate manner. There's also, you can use a directive, private directive for parallel processing to say this t is independent of all other t's in this loop. So it gives you wordy but perhaps less cryptic advice as to what you can do to modify the program that can help the compiler optimize. In all cases, you need to make sure that the advice is applicable to your program and that your program will run correctly when you follow the advice. However, having your program run fast is no good if the answer is wrong. So our products provide a lot of features that can help you find and correct errors in your application. One of the major features that we have for this is called generated interface checking. And this is useful if you have a Fortran 77 style application where you have a bunch of independent subroutines and functions, and you have not been using Fortran 90 modules with explicit interfaces. What it does is when it compiles a subroutine or function, it generates a Fortran 90 type interface that it puts off to the side. And then when it later sees a call to that routine, even if it's in a separate source file, it checks that generated interface and makes sure that the call is consistent. So it checks for number of arguments, it checks for argument type, it checks for the cases where an explicit interface is required by the language, such as you had declared an argument optional. This feature is on by default on Windows in a debug environment, so you'll get this. But if you're on Linux, a lot of people don't know about it. Use -warn interface in your build script, and it will add this checking for you. Another thing I like to suggest, not something that you would leave in all the time, but turn on standards checking and do a build and look at the diagnostics that it produces. Often we get customers who have problems in their program because they didn't realize that the compiler was giving them an extension that they didn't want. For example, free conversion between integer and logical data types. You may get many, many, many warnings from this for things that you consider perfectly normal, but you might also see something that says, well, wait a minute, I didn't mean that, and you can go and check your code. Our compiler tries to be very compatible with many previous compilers and long-standing traditions in Fortran programming, and sometimes these extensions can get you into trouble if you don't know they're there. So turn on standards checking at least once and look at the diagnostics and see what's there. Bounds checking and pointer checking, these are options. Again, on Windows and in Visual Studio, bounds checking is on by default. I think pointer checking is off by default, but you can turn that on. there is an option called FPE0 for floating point errors. Normally, when the default is that IEEE semantics are used, so if you do a zero divide, you get an infinity and not an error. Or if you get an overflow, you might get something, that's called a not a number. Or actually, it's the other way around: infinity for overflow and not a number for zero divide. And these will the program will just continue executing, and you may get results that you don't understand or don't expect. So if you turn on FPE0, this will cause the compiled code to give you an exception, give you an error when it encounters a situation like this. You may not want to run with this all the time. It will slow down the code in some cases, but it is a diagnostic just to make sure that your program is executing correctly. And then there's static security analysis, which I will go to on another slide. Static security analysis is a whole program analysis of your application. It's mixed language, so you can mix your Fortran and C code for analyzing things. It looks for argumentless consistency, use of undefined variables across program units, across files, many, many more errors. I think there's about 250 different types of errors that it can detect. It's very good at looking at OpenMP usage errors that it can check at build time. When you build for static security analysis, you don't get an executable. You tell it that you want to build for that, you add the option, and it will compile everything and do the analysis, but you don't get an executable. It looks for coding errors, it looks for security errors such as buffer overflows, again, uninitialized variables. It goes across source files, across routines, and you don't have to change any options in your compiler. You can use whatever compiler you want for generating the code, but you have to use the Intel compiler to generate the static security analysis. It does not run your application, and that means it's fast because you're not slowing down doing runtime checking. You don't require any kind of central server to do static security analysis. Every developer can use it. It is very easy to use from the Visual Studio environment. You simply select Build for static security analysis. It will automatically build your application and then bring up the list of errors that it finds. On the right-hand side of the screen, I have an example of what it shows when it finds an error. So it lists errors it finds and ranks them in order of how serious it thinks they are. So it gives you the error, and then it also, in a split screen, shows you the source of the error. So in this case, I had called subroutine sub with an uninitialized variable. Inside subroutine sub, you can't really tell necessarily that the argument hadn't been initialized, but static security analysis can tell that. Static security analysis is a suite-level feature. It requires that you have one of the Studio products, so that's Fortran Studio, C++ Studio, or Parallel Studio XE. You don't get it if you simply buy the Composer and Intel Inspector separately. Intel Inspector is used to view the results when you build with the diag enable Fortran SC or -diag enable space SC option. It creates a file that is then read by Intel Inspector. But you need to have the suite license in order to enable this feature. And speaking of Intel Inspector, this is the next tool that is in Intel Fortran Studio XE. And to go along with the static analysis of static security analysis, this does dynamic analysis. It looks at your program as it runs and checks for memory and threading errors. memory leaks. It's very good at detecting memory leaks. It can do things like, oh, you used this after you did a free, or you allocated a pointer and then lost track of the pointer, and then maybe allocated the pointer again, and you've done a memory leak that way. So it will basically instruments your code. You don't have to use the Intel compiler to build it. Of course, if you're doing Fortran, it'd be kind of silly not to use the Intel Fortran compiler. It will analyze DLLs and SOs on Linux. You don't have to have the source available. A debug build is recommended for best results, and having the source is needed if you actually want to look at the source. Over here on the right-hand side, this happens to be a C example, but Fortran will do the same thing. Again, it ranks the errors in order of importance. If you double-click on one, it will bring up the source, and if it's something like a mismatched allocation here, it says, then it will show you both the origin and the target of the mismatch. Works on both 32 and 64-bit operating systems, Windows and Linux. And again, you can use this from, it has its own user interface, graphical user interface both on Windows and Linux. Works inside Visual Studio or outside Visual Studio if you want. It can run the threaded application and look for threading errors such as data races, deadlocks, and invalid memory accesses. Here is an example inside Visual Studio when you say, I want to start an Intel Inspector analysis. So you then tell it what kind of analysis you want, and then you click the Start button to start running your program. And there's various options there. And when it's done, it brings up the analysis, shows you the errors, shows you the source, all inside Visual Studio. You can also use its independent graphical interface. We have both static and dynamic analysis, the static security analysis and the dynamic analysis of Intel Inspector. They're both useful for finding errors in your program. You would use them at different stages in your development. The dynamic analysis is good for memory and threading errors, but it's a little slow to run, so you probably want to use this towards the end of your development process. And you must have a workload so that it can look at the code paths and make sure that all of the memory and thread accesses are correct. It tends to have fewer false errors than the static analysis, and the dynamic analysis doesn't require the source, where static analysis does. With static analysis, it does tend to have a lot of false positives or error. It complains about something that isn't really a problem because it can't always be sure, based on the way the program is running, that something is a problem. But you can look at the diagnostics the static analysis gives you and decide for yourself whether this is a real one or not. And one of the nice things is that in the Intel Inspector user interface, you can say, mark an error message as, I've researched this and this one's now fixed or okay, and it won't complain about that one again. The third tool in Intel Fortran Studio is Intel vTune Amplifier XE. We've had Intel vTune Performance Analyzer for many, many years, and many people who learned to use it thought it was wonderful, but the learning curve was very steep. We've completely rethought the way that vTune is used and created vTune Amplifier XE. This is a performance profiler that runs your program and looks at where are you spending your time. It will do it by function. It can capture call stacks. So when you're in a function, it can say, where was I called from? You can see how you're wasting time. Is there lots of memory contention, cache contention for your application? If you're using Intel processors, it can use the event counters that are built into all of the Intel processors. But it will work. It can do a lot of analysis even without event counters. It can look at your threading operation and see whether a thread is waiting too long on a lock or a synchronization. You can see if your CPU, all of your cores or processors are being used efficiently in parallel, or do you have a workload that's simply shifting from one core to another and you're not really getting parallelization. It's low overhead for typical sampling type analysis. It's easy to use. You simply click a couple of buttons in the user interface, in Visual Studio on Windows, and there's user interface on Linux. And for simple types of analysis, or you can do the more traditional dig down into the individual events if you're familiar with your processor and what type of events it has. So if your program is running slower than you think it should, you run it through Intel Amplifier XE, and you can get a good view as to where you should be looking at for analyzing performance and what you don't have to look at because it's not contributing to the overall runtime. There's hotspot analysis. So you get a call tree, and then you can expand the call tree to see where things are being called. It can use hardware event-based sampling, or it can do time sampling. It does thread profiling, so it looks at how your threads are doing on each core and over time. And you can drill down into time segments to see how things are going right down to the millisecond level. You can do a normal production build and then run your production program through vTune. It works with the Intel compilers, of course, also works with Microsoft and GCC compilers. And if you have a mixed language application, C++ and Fortran, it will work with that. And even if you're using .NET, you can use Intel vTune Amplifier. So here's also an example of one of the displays of Intel vTune Amplifier. Some of the features that are in the most recent version of Intel vTune Amplifier, preset performance experiments. That's where I saw it. It has preset questions that you just simply click that and say, I want to find where it's spending my time. I want to know where my memory usage is, and it will collect exactly the kinds of events that are needed for that. The threading timeline is really nice. You see that here on this slide, where it has the threads and where which ones are using the time. It's got a nicer source view and some other new features that make it much easier to use than earlier versions of Intel vTune. And of course, with any of your Intel development products, you get Intel Premier support. When you buy an Intel developer product, you get 1 year of Intel Premier support, which includes not only technical support, one-to-one technical support from support engineers such as myself, but you also get any updates and upgrades that are released during the term of your support contract. You can submit issues through the Intel Premier Support website and look at all of your issues. If you're a large company and you have many developers, we can set up a group account for you so you can coordinate reports across your members. As I said, you get product updates and any related downloads. We also have a large selection of frequently asked questions documents, a knowledge base. Our user forums are open to everybody, and we try to give you notices when there are important changes, maybe compatibility issues or suggestions that you upgrade. Premier.intel.com is the login for getting to Intel Premier support. Software.intel.com is Intel Software Network, where the user forums are. And if you're not using user forums, I highly recommend that you visit them. There's lots of knowledge there, not just from Intel engineers, but from a wide variety of knowledgeable customers. So I've talked about Intel Fortran Studio XE, all of the pieces that are in it. They're not only to build your application so it runs fast, so that it's correct. We have a wide variety of productivity enhancing tools, some of I haven't even talked about, such as the new Visual Studio features for Visual Studio 2010, the source browser feature, and many other source editor features that are in there for Windows. You can increase your application performance and make sure that you get the correct answer so that your application gets done and time to market or time to being done quicker. You can download a free 30-day evaluation of all of our products from intel.com/software/products. You get full support during that evaluation period. And also, for people who have attended this webinar, you get a 20% off discount of Intel Fortran Studio XE from our friends at TechExtend. You must call TechExtend at the number that's shown on the screen. This number will be shown later, and tell them that you are you were attendee of this webinar, and it's good on these Intel Fortran Studio XE products. These are various license types. There's floating license types. There's box product, 3-year floating license, things like that. And you can look at those on the TechExtend website and call TechExtend to get your discount. I have a couple of things the lawyers make me show you. This is our optimization notice to let you know that Intel compilers, well, they definitely do optimize very highly. We may or may not optimize to the same degree on non-Intel processors, but as I showed you on that chart, we do pretty well on non-Intel processors too. So there's that. And then this other thing, which again the lawyers make me show you, but you've probably seen this many times already. Bunny people. Haven't seen bunny people in quite a long time. And that's the last slide here. And now our host will, let's see, oh, we're going to go back to questions and answers. Okay.
Okay, thanks, Steve. We do have a couple questions, and don't worry, that number will show up again on your screen later. It's actually at the bottom right now, 800-441-1511 to call in for your discount. Our first question is, what methods are available to create a graphical user interface for a Fortran program?
On Windows, there's quite a few features. The easiest thing to do is something that we call Quick Win. You simply build your application as a Quick Win project, and you get a Windows look and feel with a menu, copy and paste, and you can add to the menu. You can also do some simple graphics with Quick Win. Quick Win is not the answer to everything. You can also use the full Win32 API to do most anything that the Windows API provides. And there's OpenGL is available for graphics. We provide interfaces for OpenGL. On the Linux side, we don't have Quick Win on Linux. OpenGL, of course, is available. There are various graphics packages, third-party graphics packages available, some free, some are commercial, for doing graphics. And if you have specific, my recommendation, if you have specific questions or want advice about this, is ask in our user forum, because we have a lot of users who develop graphical applications on both Windows and Linux, and they can give you advice as to what they've used. I can tell you what we provide with the product, but there's lots of other things out there. Next question.
Okay. Do any of the current Intel Fortran products still include the IML library from Visual Numeric?
Yes. We have, in fact, we just released this in September. It was a long time coming, qualifying the IML 6 with Intel Fortran Composer XE, but it is now available. Visual Numerics is now Rogue Wave. Rogue Wave Software bought Visual Numerics a couple of years ago. That is now available on Windows. So it's a combination product that includes Intel Visual Fortran Composer XE and the IML Fortran Library 6 for Windows. There is one major change I want people to be aware of, is that the runtime licensing for IML has changed from before, where Rogue Wave now requires that you have individual runtime licenses when you deploy your application. We have a Q&A and a copy of the end-user license agreement on our knowledge base, and it's linked to from a sticky post on the Windows Fortran user forum. So I highly recommend that you look at that and make sure that you understand the terms. Next question.
Okay. All right. Do any of the Fortran suite components generate a caller, callee tree for understanding the structure of an application?
Well, vTune Amplifier can give you a runtime tree of what routines called what other routines. There isn't anything that I can think of right offhand that would sort of compile your program and give you a list, a tree form of the calls and callees. You can on Windows and Visual. Well, let's see. There's a couple of things. We have a cross-reference available in a listing file, so you can, for every source file, you can look at all of the routines that you can see a list of all of the routines that were called by a particular routine. In the Visual Studio environment, you can see a list of all of the functions or subroutines that are defined in a source file or a module. But as far as a tree form, I think vTune Amplifier is probably the closest to that. I've seen tree form output before. I remember back when I was at DEC, we had a thing called DEC Source Code Analyzer that would do that. And it looked really nice for toy applications, but when you got something that was a real application with maybe dozens or more routines, the tree was unintelligible. It was just so dense, and I didn't find it useful. But there are some products out there that can help you analyze a program and try to understand the flow. I'm not sure how successful they are.
Okay.
I see a couple of questions in the chat and the Q&A. I'll go with these.
Okay. Yep.
Is that all right?
It's no problem. They're just keeping on coming in, so the ones you see there might be ones before. But however it's easier for you, that's fine. If you want to address the Q&A ones, that's perfect.
I'll see. Well, there's one that says, if I have code which runs correctly in debug mode but gets the wrong answer in release mode, how to debug? That's often, sometimes it's uninitialized variables. It's sometimes optimizations that slightly change floating point results. What I suggest you do is, first of all, use as many diagnostic features as you can, those of which I discussed earlier, to make sure that your program is not, for example, accessing outside an array bounds, or you have mismatched types in an argument, or uninitialized variables. And then you can do things like, in a debug configuration, slowly increase the optimization level and see when things change, and you can still debug to some degree. This is a question that would require a very long discussion, and I encourage the user to visit our user forum, and we can discuss it there. Okay, you have another question from the audio or whatever?
I'm just taking out all of the questions from the chat and the Q&A and just making a big list and going down the list. That's all.
Okay, so go ahead, take the next question.
All right. I have Fortran XE 2011 with VS 2010 shell. How do I determine if I have the turning and analyzer access?
If I have, I'm sorry, the what analyzer access?
it says, how do I determine if I have the turning and analyzer access? And then how does the turning, oh, maybe it's supposed to be tuning. How does the tuning and analyzer tools work with MPI?
Oh, okay. Well, you could look at your, let's see, how would you know? First of all, you'd look and see at your system whether you have Intel Inspector XE and Intel VTune Amplifier XE installed. Those will show up on your system. You can look at the license file to see if you have a license for it. If you bought Intel Fortran Composer XE, that doesn't include the Inspector and Amplifier products. You would have to buy one of the Studio products, Intel Fortran Studio XE or Intel Parallel Studio XE, to get those products in addition. They are also purchasable separately, but as I mentioned, even if you buy Intel Inspector XE separately, you don't get the static security analysis feature unless you buy the suite. As far as MPI, there is no direct support for MPI in the analysis tools.
Okay, I have purchased Visual Studio 2010 Professional, and I've had lots of problems trying to get to know how to use the program. Are there simple tutorials to show how to enter a simple program, compile it, and use a debugger?
Well, I do have a tutorial on our website that goes through using Visual Studio. It's not specific to Visual Studio 2010. I would encourage the person who wrote that to post the question on the user forum, and I can certainly direct them to a little animated tutorial that goes through the steps and help them get started. If you've never seen Visual Studio before, it can be a little bit daunting. If they are somebody who's come to the Intel product from the digital or compact product, there is a migrating from compact visual Fortran document, again linked to from our user forum site, that is very helpful in explaining the differences, and I would encourage them to go there.
Okay. Does the inspector identify use of uninitialized dynamically allocated arrays? There is a command line option to check uninitialized variables, but that does not apply dynamically allocated memory. Also, does it detect out-of-bounds access where an array is passed from one routine to another and the size is misdeclared in the second routine?
There's a variety of diagnostics that can help with some of those. The thing about the dimensions misdeclared, actually the generated interface checking can help with that. Intel Inspector will also, well, actually the static security analysis can detect things such as mismatches of array sizes. Intel Inspector will look at out-of-bounds memory accesses and can detect those. Uninitialized variables, again, Intel Inspector and static security analysis can look at that. I agree that the compiler option for uninitialized variable checking is very limited and doesn't do as much as one would like it to. Next question.
Okay. I guess there are not so many books on design pattern in Fortran 2003, and unfortunately the only one I found, Scientific Programming the Object-Oriented Way, uses a lot of Fortran 2003 features not yet supported by Intel. Do you have a timeline for full Fortran 2003 support?
There's only two even semi-significant features from Fortran 2003 we don't support. One of them is user-defined derived type I/O. The other one is parameterized derived types. Neither of those are widely used. I would be surprised if there's a textbook that's recommending them on a general basis. But we do intend to fully support Fortran 2003, but I cannot give a timeline at this time.
Okay. Could you please describe do concurrent? Is it similar to par4 in MATLAB?
well, what it is, if you've seen the for all construct that was in Fortran 95, a lot of people thought that that was a parallel do loop. Do concurrent is more of what looks like a traditional do loop, where you might be doing some array assignments or calling procedures, but instead of saying do I equals 1 to 100 or something like that, you say do this over this range of values for I. So, for all values from I from 1 to 100, and you're telling the compiler that it's okay to do any of those iterations of the do concurrent loop in parallel. The old for all construct was not easily parallelizable because of its semantics. So I say do concurrent is for all done right. I don't think I could compare it to MATLAB, and I don't know the other product that was the customer mentioned. But it is something that would be much more familiar to a traditional Fortran programmer. And the compiler, if you ask for automatic parallelization, will try to parallelize a do concurrent loop. Parallelization is not guaranteed, though.
Okay. Do you have examples of coarrays calling subroutines? And is there a way to exit all of the generated images within the main program?
We don't have an example, a good example of coarray usage. In fact, I'm working on one right now. There are some examples out there on the web. As far as having all of the images stop execution, that is the error stop statement in Fortran 2008. That's what that's for. And error stop means all images stop execution now. Coarrays is a multi-day topic to go on, but I'd be glad to answer more questions about coarrays on our user forum.
Okay. We have time for just a couple more questions here. Does the Intel Fortran editor include the feature to find the definition of a variable or function that you highlight and then right-click on? I used it at one point.
I'm sorry, say that again. I think that's the go to definition or find all references. Yes, we do support that in Visual Studio 2010.
Okay. Okay. And our last question for this session is, I have managed to get MATLAB integrated with XE SP1. How should I best determine the necessary paths to include in path, lib, and include for linking Fortran with other languages / products?
Well, I would recommend that that the environment that you run MATLAB or whatever is invoking the Fortran compiler be started from what we call a Fortran command prompt, which has run the I guess it's composer vars or compiler vars.bat file that establishes the various lib and include paths, or you can run that directly. If you look at the compiler release notes, it gives instructions for how to run that command procedure. Or you can run it and look at the values of lib and include and make sure those things are defined for you in whatever environment you're using the compiler from.
All right, well, thank you, Steve, for an interesting webinar. Thank you, everybody, for attending today also. And all right, so on the discounts for the Fortran Studio from TechXtend, so all attendees are eligible for 20% off of MSRP for purchases by November 30th, 2011. Good on the following SKUs listed below for the Windows and Linux version. They are not available on the web, so please call 800-441-1511, or you can email requests for quote and also questions that have not been answered today to salesassist, SALESASST @techextend.com, and we'll be happy to help you. So again, thank you, Steve. Thank you, everybody, for attending, and have a great afternoon.